Welcome to the session with Rob. Rob is happy to answer questions, so I'll be monitoring the chat and I'll be interrupting at an appropriate point to ask the question. We're quite a small group, so if you want to come off mute, you can ask it yourself. But other than that, I'll go on mute and off video, and over to you, Rob.
Okay, yeah, so I'm going to be a bit time poor in this one. I think this normally comes out to be about an hour. So I'll go as fast as I can, but we might not get through all the slides, but we'll just have to see how we get on. Okay, so this RACF, I love this quote. This is a colleague of mine. RACF, million lines of code, and all it does is say yes, no, or I don't know. This presentation is trying to bridge the gap between systems programmer, security administrator, and someone like me who's a software developer writing system software tools. I've been a systems programmer in my time as well, going back like 20 odd years ago. I was a sysprog, and I remember thinking to myself, why are they asking me to do these RACF things that they're asking me to do? How does it make sense, stuff like that? And now I'm on the other side of the fence, where I'm actually writing software that does security checking. And I just want to sort of like explain some of the thoughts that we go through when we're designing our product. So that's more on the the software security design thinking, what we are considering when we are doing our security posture inside our software. We're going to have a chat about resource names, how we come up with that, what we should use, what we shouldn't use, class selection, how we consider the classes that we use for our software checks. We'll go through some memory cache implications for various profiles, going into messaging and logging. And if we get a chance, we'll go through some identity and authorization implications for RACROUTE as well. Okay, so background, RACF, if you go back to the early days, the legacy implementation, you had individual macros for all of the various RACF services that you call RACStat, RACCheck, RACInit. Yeah. We did have at the time other ISD competitive products, ACF2, Top Secret spring to mind. So RACROUTE was introduced to provide a router for all of these functions, which allowed easier implementation for all the other ESMs to get their hooks into the system safely and start doing their flavor of security checks instead of the RACF. Okay, if you are a developer of system software and you are thinking about doing some security checking stuff, you should be using RACROUTE rather than any of those old RACStat and RACInit sort of style and RACCheck style macros. Okay. This scope of this presentation, I'm going to talk about mainly RACROUTE request equals auth and RACROUTE request equals farforth implementations. I'm not really going to deal with the request equals verify, i.e., how you enter the system, how you authenticate to the system. I'm just going to assume that you've got a password, a passphrase, a certificate, a token. You're validly on the system when we're talking about how we're then going to do authorization checks for that identity. So the software security design thing. So this is the thought processes that someone like me goes through when we're thinking about our posture and how we're going to do things. So what are we protecting? Is it usage of all or part of our software product? Is the user permitted to use our product full stop? Is he perhaps restricted from accessing subcomponents of our product? Do we need to build a custom UI based on permissions to various resources to give him a better user experience, or to ring fence him away from knowing certain things about what we're showing to him or her? Do we need different levels of authority for abstract resources? The user might have a different role or persona inside our software. We could have processing logic that could take a different path depending on whether he has an access level above read. Okay, staff access levels are hierarchical by design. So you have none, you have read, read's above none, update's above read, and includes read. Control is above update, which includes update and read. alter is top of the tree. Okay? It is possible that your security posture might have a non-hierarchical approach. Okay, so if you do that, then perhaps you're going to need the privilege might have to be part of the resource name that you use to protect. Okay, so that might be something you need to think about. Maybe we're doing courtesy checks against resources that are owned by other components. So STSF is a very good example of this. So when a user does something like an action against a row on one of our panels that results in maybe something that JES does or MVS does, and we know as a supplier of that interface that that is going to result in a SAF call by those components. Now, if we just shoveled on that request to the component and that component fails the request, you might get a very big ICH 408i nastygram from that component to sort of say, you're not allowed to do that. That's going to appear either in your terminal, it's going to go to the syslog, it's going to be quite ugly. Okay? So sometimes we'll sort of say, well, we know what that resource is going to be, so we're going to do a quick courtesy no logging call to the security product to say, is this guy allowed to do that? If he isn't, then we're going to give you a nice little graceful access denied message on the terminal, and you don't gather the attention of the people looking at the syslog or your auditors or anything like that. So we're doing it on your behalf. Another option is that perhaps, there are certain customization options about our product that we want to enable or disable. Maybe our product doesn't have a palm lib member that's read at initialization, something like that. So we could have what's called a switch profile, where we would just do a quick check to say, right, has this guy got read access to this switch profile? Though he doesn't, that means that that customization option is off. So we can use that as well for an effective way of doing customization. Right? We need to think about the scope of the resource that we're going to check. Do we need some sort of system name qualifier? Do we need a subsystem or group qualifier within a single system? Maybe that's a KICS region or DB2 subsystem or a server address space or some other intra-system grouping, JESMAS, anything that we need to think about the scope of the system. And we also need to think about when the security administrator is defining these profiles, are they going to use asterisk masking for things like the scope, the system, the subsystem, whatever. Okay, so we need to carefully think about that in the design of the resources. Where are we making our security authorization checks? Right? Are we part of an authorized job step program? Are we a service that is provided to client address spaces that aren't running authorized? Okay, so again, typical case here, TSO user, right, asking SSF to do something. It would be ridiculous of us if we had the SAF check done in the problem state code, all right? Because that would just be crazy. You could get around it. You could change the problem state code. You could bypass the auth check and stuff like that. So you have to ensure that the security check is being done as part of the authorized service. So there's no way of bypassing it. Are we in some sort of exotic state? Are we cross memory? Are we SRB mode? Those sort of considerations are very, very important to design which classes we use and which service we use to do the authorization check. And the other thing to think about is, can we locate caller identity from a trusted location? So what I'm implying here is it's very poor design to get the client to tell you who he is, right? Clients should not be sort of saying, oh, by the way, I am called IBM user, even though they're not IBM user, they are some other TSO user ID. Okay, so we need to always be able to drag that caller identity away from trusted MVS control blocks beyond the control of the client that's calling us. Are we going to provide any sort of, as a software product, SAF processing exit points? I'm very much against this now. I don't really like these. I think if you're going to sort of say to the customer, change the security logic in a product, go back and use the RACF exit points. Don't use ours. Okay, but if you're going to use one of ours, then perhaps the pre-SAF is about the only justifiable one, where we give the option to perhaps change something about the environment or the profile or whatever before we do the SAF call. I really don't like post-SAF exit points to alter the decision from SAF. The whole point of using SAF for things like this is it's the arbiter of your resource checks. It is the logger. It's your audit trail. So I don't like to alter the decisions that have been made from SAF. We do need to think about the I don't know situation that you can sometimes get back from a RACROUTE. So an I don't know, otherwise known as a return code 4 from SAF, is that he can't make a decision for some reason. It could well be that the class that you've used isn't active. It could well be that the class is active, but there's no covering profile that matches the resource that you've specified, okay? So modern day thinking is, if access hasn't been explicitly granted, deny the request. So treat return code 4s as return code 8s. And there are certain products that do that by default, okay? Historically, there's a lot of products and components that treat RC4 as okay. You know, if you can't be bothered to protect this resource, then the attitude is that we're going to allow you to do the thing, okay? So you have to think about that. And perhaps as a software product, you might need to have some sort of option to tell the software how you want that to do, because in certain situations, that might be good to treat it as a permission, but in other situations, you might want to treat that more strictly, and you want to deny a return code 4. So you need to consider that. Okay, so basic RACROUTE syntax. As I said before, we're going to deal with basically request equals auth, request equals fast auth. And this is what, if you're coding it in assembler, this is what you are going to be looking at. I mean, this is the meat of a RACROUTE specification. There are other keywords, and there's quite a lot of keywords as well. But we're going to go through in this presentation the various things that relate to these keywords, and we'll cover most of them in the rest of the presentation. So generally, before we get into specifics, there are some general keywords that you're going to specify in RACROUTE. So decouple equals yes or no. There's a historical thing called the RACF router table, where an installation could opt to bypass RACF for certain combinations of subsist and requester. No one in their right mind is doing this these days. So decouple equals yes means don't bother using requester and subsist for a router table, just use it as some sort of interesting tourist information for the RACF call. And the great thing about using requester and subsystem is they're just 8-byte character values that get put into things like the USMF80 record, so you can see them, you can log them, okay? Good for diagnosis, good for tracing, okay? So I always like using requester and subsystem on my RACROUTE calls. You are going to have to supply to RACROUTE a 512-byte work area. Okay? This is a required field. Be careful to remember, it is actually 512 bytes long, okay? Not 256, not 32. Very easy to get that wrong, okay? And you'll need to specify to RACROUTE what format of the parameter list you are passing to RACROUTE. So it's the release keyword. Other modern macros in IBM space have things like plist for and stuff like that. But in RACROUTE, it's release equals. And certain keywords that you specify on RACROUTE require a higher release number, a higher version number for the parameter list. And there are 3 formats for this. The very old format is release equals version.release. It's going back a long way. Then RACF changed that to be the last 4 characters, the FMID. So you could have 77 something something. The more modern approach now is to go along that sort of convention of plist for. They have PLD and a number. Okay, so this is what I'm using now, PLD, and then you have some. I think I'm currently using 00001. Okay, so that is what I use on all my RACROUTE calls. So resource name considerations. So general good practice, if you own a software component, you have a product prefix. You have your 3-character product prefix that dictates it's you. It's your namespace. It's your, I can be installed in an SMP CSI with other software products. It's my unique 3-character prefix. And I always strongly recommend that all resource names start with your owning product prefix, even if you use, you've got your own class. SGCF has its own class, right? And yes, I know I'm a hypocrite. We have resource profiles in the SGCF class that do not start with ISF, but that happened way before I was involved in the source code, and I don't have a TARDIS, so I can't go back and change it. After that, high-level qualifier. Other qualifiers you might want to consider is maybe a function name or a major name or an object name, and maybe some grouping criteria, maybe some subsystem or region names and scoping. And those are all the things you need to think about inside that resource name. And then you're going to build it up like a dataset name with qualifiers and dots. And we list some examples here at the bottom. irr.radmin.settrops.list. That's an actual resource profile that's used to protect settrops list from radmin for RACF itself. Okay. STG admin, IDC diagnose catalog. So that's from SMS arena. Health checker profile there. And we've got the system name and second qualifier. We've got an owner here of IBM alert. We've got a subcomponent here. And then we've actually narrowing it down to the ability to browse the messages for that thing. Okay, so that's sort of health checker. Last one is from SGCF. So that's the ability to actually use SGCF as a product on that Psi1 system. Okay, so we have a very simple 3-character resource name for that. The other thing you've got to think about is if you do have a quite complex piece of software, you're going to have hundreds or tens or maybe hundreds of resource names across your code base. So you really don't want to be hard coding them in stream to individual CSECs, okay? You really need to start thinking about, well, okay, I need to manage this properly. So maybe a better approach would be have a big table of resource names with some sort of index value so that users of that profiles can just refer to that profile via some sort of index value. And that's going to simplify your maintenance and also give a nice level of indirection between the code that uses the resource and the definition of that resource in the first place, okay? Because what you're probably going to have to do with that resource is build up some sort of variable replacement logic where you have a qualifier that you need to replace it with maybe the system name or a job name or something like that, okay? So you're going, if you think about, you put your resource name templates in a table, you can then have some sort of callable service to take that template and populate it with all the variable inserts that you need to produce the final text that represents that resource name. So how do, once we have that resource name, how do we give that to RACROUTE? Well, there's a couple of ways of doing it. The legacy way of doing it is just entity equals some sort of resource name address. It's pointed to just a field in storage, and it's left justified and padded to the right with blanks to the length of the profile that the class expects. So each class has got a definition where it says how long its profiles must be. That's the simplest way of doing it. A more modern way now is the entity X keyword, where it points to a structure where you have a 2-byte length field of a buffer, including subsequent second 2-byte length field of the resource name if you have worked out how long it is. If you leave that to 0, RACROUTE will do it for you. And the IBM recommendation here actually is that you specify a length of 255 in the buffer length, and then you can populate the next length field if you want. As I said, 0, RACROUTE will do it for you, followed by the resource names. And that allows you to cater for perhaps any increase in maximum profile length that could happen to the class. And I've been assured by Mark Nelson that has happened at least once. So this is how I would do it now. I would code it this way. All right, so that's the resource. Let's think about
Rob. Mark's
yes.
actually on the call. I don't know if he wants to chip in and validate that or put it in the chat. But anyway, I just thought I'd let you know he's on the call.
Oh, okay. Thank you. Hi, Mark. You're here to troll me. Okay, let's think about class selections. So each class has attributes, they vary. And there is actually an ICH ERCDE macro that defines a RACF class. And in here we have things like the maximum length of the profile, the syntax rules for the first and other characters in the profile name, default return code if there's no matching profile, default universal access, whether or not the operations attributes grants access to profiles in the class. So there's lots of basic class attributes. But before, going back to legacy, going back to the 60s, the 70s, perhaps even the early 80s, you had the ability to have a hard-coded RACF-defined class in what's called the class descriptor table. And there was a set of those. Early on in MVS history, RACF developers realized that they needed this sort of general purpose resource class, and they added something called the facility class. And that was made available to other IBM components, and ISV software products also jumped on that wagon as well, because it's much easier to use an existing facility class profile than having to define your own classes to the system. Inside the facility class, the recommendation for non-IBM products to have some sort of national character symbol in the first qualified resource name. Some ISVs followed that, some didn't. Okay, and over time, facility class gained popularity, but it had a couple of restrictions. The syntax rules, might not be appropriate. The most obvious one is the maximum profile length of 39 characters. So if you have come up with your well-designed profile name template, and then you realize you could go beyond 39 characters, then you're out of luck if you want to use the facility class, okay? So what would happen then is that you'd probably have to go about getting another class. And if you're not an IBM component, you are going to have to use instructions on the installation manual to add your own class to the list of classes in what's called the class descriptor table, CDT. And using that ICH ERCDE macro, you can run some assemble jobs that would build the new classes that were going to be added to. And that would be active at the next IPL. Those classes would be included. If you were ISV, the class names must include a national character in the name. Again, there was no police to stop it happening. And there was no namespace convention for the ISVs to adhere to. So Broadcom, CA, BMC, other software companies that have ceased to exist had their own naming standards. And also, it was a bit of a pain for systems programmers like myself. You get a piece of installation instruction. Oh, by the way, you need to add this SAF class to the CPT. Then you've got to stick it into your user mod that you will have for the other software products. And you needed to IPL to add the new entries to your system. Okay, so it's very, very sort of dated way of doing things. So ZOS 1.6 came along and they introduced the dynamic CDT facility. So the great relief here is that you can define new classes without an IPL. And these classes are just defined as profiles in a new CDT class, okay? And so you have the same namespace considerations as the old static way of doing it by ICH ERCDE. And then ZOS 1.7 came along and they added the X facility class. And they gave the relief for the maximum profile length. So we're now at the absolute maximum you can have, which is 246 characters. So you've got a lot more namespace room for you to have your exotically templated resource name profiles. And the first exploiter was IBM Health Checker. And then they realized it was so good that they rolled that back to ZOS 1.4 via an APOL. And it really is a good choice for products to avoid having to define their own classes. But unfortunately, you still can't use mixed case inside the X facility class. So if you still need mixed case, you're going to need some other class. Okay, how do you specify the class name on RACROUTE? Okay, the easiest way, I suppose, programmatically, is you can stick it inside some quotes. So it's just a literal value of a 1 to 8 byte class name. Or you can point it to an address. And this comes to my absolute craziest thing about RACROUTE that it just blows my mind every time. The format of this field depends on the request equals specification. Okay, so and it's even crazier when you think that request equals auth and request equals fast auth use different formats. So if you're doing request equals auth, you've got to have a 1 byte length field followed by up to 8 bytes of class name. If you're using request equals fast auth, you have an 8 byte left justified class name padded with blanks. Okay, yeah, not RACF's finest moment. And if anyone used to watch Malcolm in the Middle at the military school bit, the commandant used to say, "You may thank Cadet Nelson after I leave the room." I would encourage a similar approach. Okay, profiles in memory cache. So using memory rather than doing an I/O is always a good thing. I mean, using memory to get something is just like popping down to the kitchen, taking something out of the fridge versus walking to the moon and back. Okay, so putting things in memory, really, really good. So we can optimize the performance by using a memory cache instead of doing I/O, but also it allows us to use profiles when perhaps I/O to the RACF database is not possible. Okay, and the main technique we use to do this is called global rack listing. Okay, so the profiles are actually stored in system-wide data spaces so that we can access, using the RACROUTE, we can access the profile copies in that data space. There are some other memory cache techniques available. I'm not going to go into them here. You can actually do local rack listing inside private storage of a single address space. There's something called gen listing. There's your own, RACF maintains its own anchor table entries, these gates, which is like 64-bit cache of the last few profiles been accessed. And there's a global accessing table as well. I'm not going to deal with those things in this presentation. So how do you define this? Well, it's an attribute on that old ICHR CDE macro or attributes inside the CDE class, whether or not you are going to allow your profiles to be rack listed. And you have a rack list equals allowed or disallowed, and then you can actually say if it's mandatory whether you rack list. So there's a RACL required equals yes or no. So how do you actually activate this? So there's a TSO command, settrops rack list, open brackets class command will actually make it rack listed for the first time. Afterwards, if you want to refresh those profiles, there's a settrops rack list class refresh command, or you can do it inside an authorized program. There's a RACROUTE request equals list service where you can, an authorized program can do the equivalent of a rack list class name. Okay. So what actually happens when that rack list occurs is that the RACF database is read, and all of the profiles are then uploaded to a data space, and then the in-memory CDT, the CDT is reflected by a sequence of control blocks in common storage that will be updated to point to that data space, okay, inside the entry for the CDT. If there was a previous data space for previously rack listed profiles, i.e. you're doing some sort of refresh, okay, after it's successfully switched to the new data space, it's going to delete the previous one. Applications cannot refresh global rack listed classes using RACROUTE request equals list. The RACROUTE request equals list can only be used to rack list for the first time. Okay, if you are maintaining sort of memory cache, identity and permissions inside your software, you might want to listen to various RACF ENFs so that you can invalidate or remove your own entries. A good example here would be there's an ENF that's issued when a user is revoked. Okay, so you might want to take actions on that to purge or update your own in-memory store of that. Reasons to rack list. Obviously, avoiding I/O is great, but you are going to obviously increase your memory usage when you do that. But from a system software point of view, probably the most beneficial reason to rack list is that you can do authorization checks where you can't do I/O to the RACF database. So the sort of things we're talking about here, you're in SRB mode, you're in some sort of cross-memory mode, and a lot of system software products use this ability. So going back to when I was a systems programmer in my early 20s and I didn't understand much, it was sort of like, the instructions would come along. Oh, by the way, you must rack list this class. And I didn't really understand why I was doing it. I was just a system programmer and I followed the installation instructions. But now, many years later, I know exactly why those instructions existed. But there's another really nice thing about rack listing is that if you have rack listed profiles, you can take advantage of the RACF vars class profiles. So you can have your own variable names, right? And you can give your variables values. And if you specify your variable names in your profile and then you rack list it or refresh it, it'll unroll all of those values inside the rack listed data space, and you will just get all your profiles. So for example, here, n1.mygroup.myjobs.asta.asta.asta, and just for it'll unroll. If I've got 3 variables for my group and 8 variables for my jobs, I'll get a Cartesian product of 24 profiles that will be created inside the rack listed data space, which is a nice way of grouping up things to provide that sort of grouping function that wouldn't natively be available. So that's a really nice little side effect of doing a rack list. So using rack listed profiles, okay, so if you're in SRB mode or cross memory mode and you do a rack list request equals fastall, you're good to go. If it's rack listed, you're going to get a decent response from RACROUTE. If you try doing a request equals auth, you're most likely going to get some sort of horrible event. Okay, if you're in non-cross memory mode, you're in TCP mode, and the CDT entry states RACL required equals yes. Again, RACROUTE request equals fastall, but it's going to be good. If you try using RACROUTE request equals auth, you're going to get a bad return or reason code. I don't know what combination it is, but you're going to get a non-zero return code telling you that that's invalid. If you're just in TCP mode, RACROUTE request equals auth and fastall. If the profiles are rack listed, then the RACF database can be avoided. So if it's fastall, it's rack listed, you're going to get a good performance gain for that. There are some niche differences in behavior between RACROUTE request equals auth and fastall in this circumstance, and you can actually check the RACF manuals there for more information. I don't want to go into those. Okay, how are we doing for time? Half an hour. So, okay, it's not too bad. All right, messaging and logging. There are some keywords on RACROUTE that relate to your messaging and logging options. Message sub equals yes or no. Default no. You're going to get a nastygram. You're going to get the ICH 408I, but you can opt, if you're authorized, to suppress that. You can opt to get the message that would have been issued to the syslog, to your terminal, back in a caller supplied buffer. Maybe you want to parse it. Maybe you want to stick it somewhere else. Okay, and if you're doing that, you can also give a subpool for that buffer. So, and it's up to you afterwards to then release that buffer. Okay, so RACROUTE will write the message into your buffer, and then you'll do something with the buffer at a later date, and then you have to release it. RACF will not release it on your behalf, which is why you need the subpool number so you can do a correct storage release using that subpool specification. Logging keywords. So you've got 3 here. You've got log equals as is, which is as specified by the profile that protects the resource or any other of the global options. Log equals no fail. So if access is denied, do not log the attempt. Okay, use as is logic for successful access. We'll explain how you might use that a little bit later. Log equals none, so no logging at all. No messages are issued either, regardless of whatever you specified on message sub and message return. Log equals no stat is like none, but no statistics are generated, regardless of setrop settings. You can, at the same time, give a log string. So this is a string that's going to be included in any SMF80 records. You can give the traditional format, log string equals was up to 1 byte length field followed by 0 to 255 bytes character data. But if there's a log string X, yes or no keyword, so it allows you to specify a greater number of bytes, where you'd use a 2 byte identifier, a 2 byte length field, 2 byte identifier, and up to 1100 bytes of data if you so wish. Okay, I like log string because, you know, if I'm diagnosing security checks, I'd like if my program that's doing the check can give me some extra hints about why, where, and what it was doing at the time. That's great. That's going to come out in the SMF 80 record. So I think at this point it's sort of important to differentiate between your user's access intent. Okay, so um, there's a difference between when your user is trying to do something deliberately or whether your software under the covers is making some SAF checks on their behalf, maybe going back to those switch profiles we talked about earlier. Okay, so deliberate actions, you know, you probably want to log it and message it. You know, you're going to get an ICH408I. You know, that is a user deliberately trying to do something they're not allowed to. With indirect action, you might want to make what's called no logging calls to SAF because you're doing it on their behalf. They're not deliberately asking you to do something for you. Okay, so in that case, it's probably good to do no logging. A good example here also is some ESMs, ACF2 in particular, can have global options within their configuration to say after a certain number of violations from this certain user, you're either going to cancel the user or you're going to revoke him. Okay, so if you, as a software provider, don't pay attention to that, your product could inadvertently get the user cancelled or revoked just with him trying to invoke your product. Okay, so you have to be very, very careful. So log equals no fail. So I'm going to give you an example here. This is a very simplified example of a DB2 authorization check. Okay, I'm not a DB2 person. I cribbed most of this from a colleague at Rocket. Okay, so we're going to do this SQL statement, select asterisk from netbank.table name, okay, and in subsystem DSM table. So what's going to happen with DB2 is he's going to do a sequence of fastauth log equals no fail calls for read access to a variety of profiles. Okay? So the first thing he's going to check for is, has the user actually got access explicitly to this table? Okay? If so, that's great, he's off. If he hasn't, we're going to say, well, maybe he's a DB Adam. So we're going to do a check for that in the MDS. I've left the class name here. There's a DB2 class that will be checked as well. So he's going to check that. If he's not DB Adam, maybe he's sysadmin. Okay, so we're going to do another check. Okay, against the sysadmin. So if he fails the first one, fails the second one, and then hits the last one, that's great. Okay, and that will be then a log equals as is. That's great. He'll get his access on there. If we get RC8 from the last check, what we're then going to do is redrive the RACROUTE from the last check with log equals as is and message sub equals no. So you actually get your correct logging, okay, for that access attempt. Okay, so that's the example of how the designers of DB2 thought about their security posture, how they're successfully logging the access and it's coming out with the correct things to make the auditors happy. Okay. Identity and authorization. So when you successfully authenticate to ZOS, you are going to have something called an Access Environment Element Control Block, an ACEE, built on your behalf. This actually is owned by the SAF component, not RACF. And there is a mapping macro for this, IHA, ACEE, and it's supported by all of the ESM, so RACF, ACF2, Top Secret. I believe that ACF2 and Top Secret might not populate all the fields that RACF does. I'm pretty damn sure that they don't. But there are certain common fields that will be specified. And one of them, obviously, is the user ID. It says ACE user. That's contain your 1 to 8 character user ID. You have flag bytes within there that have bit settings for your privileges, like special and operations. And there's other environmental installation information pointers and control information in that block as well, including pointers to your port of entry. Maybe it's your port of entry to terminal, maybe it's a console, maybe some sort of server auth. So it enables you to do conditional access list processing. Like a good example here is SDSF users. We use that port of entry of SDSF so that we can have when console SDSF. So that allows us to say, this guy's allowed to do this operator command only when he's inside of SDSF. Outside of SDSF, he's not allowed to. Okay, so it's a really nice little extra check that we can do. When an address space, has executable work to do, he will have at least one ACEE, which is created by RACROUTE request equals verify or other callable services. And this is where I give a big shout out to Mark. There's a fantastic GSE presentation called The Life and Times of an ACEE, and there's a link there in the slides for you to go and have a look at that. So where is the ACE? Well, at the address space level, ASCB points to your ASXB, and there's a field in the ASXB called the SendV, ASXB SendV, and that will point to your ACEE. At the task level, because you can have multiple identities within the same address space, you can have an ACE associated with your TCB. So there's a TCB SendV field. Okay? That can point to an ACE, and that's like the default place where RACROUTE request equals verify will stick a newly created ACE. But TCP SendV can and frequently is zeros for many subtasks in the address space. So you go and have a look at your TSO address space. You're going to see TCP SendV as zero for most of the TCPs within that address space. The other time we'll find an ACE, they can be free floating. So address spaces that have multiple identities, multiple user address, multiple user IDs can be authenticated in the same address space, something like KICS. They're going to maintain their own tools and lists of ACEs, and then they can choose to use them when they're doing various RACROUTE requests later on. So, quick shout out for the SDSF.
Sorry, Rob, before you go on to the next slide, three minutes left.
Oh, Jesus. Oh, right. Okay.
You did say it was going to be tight, didn't you?
I did. We're not going to get to the last section then. Okay, so SDSF can show PCBs, and there's an ACE pointer here at the end. We've got some enhancements coming to that soon. What I wanted to get to really was how you would use ACE on a RACROUTE. So request equals auth, you can pass in the ACE address. You could also pass in a user ID specification or a group ID specification or a user token specification. Okay, and then that can be used on your request equals auth as well. Request equals fast auth, you can just pass in the ACE address and ACE ALET if that's in a different space to the primary address space. Now, if you pass in nothing, that's called a first-party RACROUTE check. So what will happen is RACROUTE will locate the identity, hopefully from the TCB. If he's not in TCB SendV, he's going to drop back and use the ACE from the ASXB SendV field. Okay. A second party check will be where RACROUTE has actually passed the ACE and optionally the ALET for the ACE on the call. And a third party check where you actually, what's going to happen, the user ID and the group of the U tokens have been specified on RACROUTE. And what will happen then is it will create an ACE and use it for the request equals auth. Okay. So RACROUTE request equals fast auth cannot perform third-party auth checks. And there's a very good reason for that, is that it can't do the IO to the RACF database to create the ACE. Okay, so request equals fast auth can only use first and second party checks. Okay. Quickly go through common RACROUTE mistakes. RACROUTE rules. Rule 1, understand or follow the restrictions in the manual. Obvious rule here, and this is Mark Nelson's supplementary rule. Not following rule 1 can lead to unpredictable results, can include application outages, system outages, alteration of the orbit of planet Earth, human sacrifice, dogs and cats living together, and mass hysteria. So RACROUTE can be complicated. Have a look at the manual. It really, really helps. Mistakes made by people who should know better, and this includes myself and Ken Jonas, who are SDSF developers, and it includes Mark Nelson and Bruce Wells, from the RACROUTE team as well, we've all made these mistakes, okay? So omitting or misspecifying the work area keyword, you're going to get OC4 bands, you're going to get some storage overlays perhaps, getting the wrong class equals flavor, my favorite, unexpected non-zero return codes. And if you have perhaps an inconsistency on your release specification between your MF equals AL and MF equals E forms of the macros, you might get some sort of silent overlay or OC4. Okay. So that's got to the end just about on time. that was tight. So any other questions, comments?
No questions. Mark did add some additional info in the chat about rack list.
Fantastic.
I think this is, I don't know how many chilies I should have given it, Rob, but I probably under-chilied it on the agenda. Really fabulous detail. And as I was saying to you before people joined, I think this is something that people will Google in months or years to come and find it and go, wow, thank goodness I've got this recording and these slides to help me through dealing with some of the detail, including the pitfalls that people have made. So thank you very much for the content.
Okay,
excellent.
Thanks everyone.
Thank you to all the attendees. The recordings normally come out in 4 to 6 weeks on Vimeo, so you'll be able to re-watch all of that and consume it. I'm sure Rob is open to being connected on LinkedIn with you if you've got any other questions. And
absolutely. Yeah.
Maybe you might even be lucky enough to bump into him at
GSE. Yeah.
Yeah.
In November.
Not GSE. GS UK. Thank you.
GS UK in November.
Open brackets, independent, close brackets. Yeah. Anyway, lovely. Thanks everyone.
On so the Systems Enthusiast Discord channel as well. I participate on that. So if you want to join that, we can chat as well.
Beautiful. Thank you, everyone. Have a good day, morning, afternoon, whatever it is. Thank you.
Cheers. Bye-bye.